What's going on? We are doing differentiation, and you remember before we have a look at how to differentiate quadratics. So basically that's sort of the function consisting of several terms and help you understand how it works. So today we're gonna go through more general idea, and we are going to differentiate functions with two and more terms. There might be polynomial functions, there might be x including negative powers and thirds as well. Let's have a look there. So that's the revision for Edexcel exam styles questions. I hope you like that. The first is pretty easy. You need to find the gradient at the point Q for the following polynomial, okay? You clearly state that you're given a polynomial. Alright, so pause the video, try to do by your own, and let's get started. Okay, so we are given several terms. We actually need to use rules for addition, for sum, or difference of derivatives. So that's pretty easy and pretty obvious. And of course, power rule of differentiation. So x to the power n. So make sure you know how to do that. All right, so let's find the gradient. So the gradient is g dx. So in our case, it's g prime. First of all, I'll find the general derivative. G prime is going to be negative. So 3 and 3 will give us 9x to the power 2 plus 4 and 2, you'll get 8x. And there is the constant which gives me 0 as a derivative. All right, so that's general equation for derivative. Now we plug the point, the x coordinate, -1, and see what the gradient is at this point. All right, so let's try to plug -1 and we'll get -9 and -8, so we'll get -17. All right, so that's the gradient. So this is the gradient of the function g at the point when x is -1. All right, so let's go next. Here is a bit more challenging problem. Pause the video, try to do by your own. So you're given a function in the form, in third form actually, where a, what you can see here and here, a is the constant. So if f prime, so this is df dx from 1 is equal to 2, you need to find a and give your answer in the third form. All right, so let's try to do that. So first, I would rearrange and make a bit different form for the fx. So in which way I would like to rearrange? So all the powers, all the thirds I'll convert into the powers. Just remember, nth root of x is simply x to the power 1 over n. So that's rule or features for indices I will use there. All right, and also I will use that x in the negative n is simply 1 over x to the power of n. So that means you just simply flip it over. All right, so we'll put 3 over a. Then I'll get the power x to the power 3, because here is the imaginary 2. So that's why it's -3 over 2. I'll both use that and that property. On top of that, there was m as the power of x, so that's why m is going to be on top as well. So I use that, and I add also 2a, and x is going to be to the power 1 over 2. All right, so now I have the general structure, sort of polynomial structure. However, it's some sort of negative and fractional powers. I'm not fear of that, because actually this is what you need. So that's the general form that you need to get first of all. All right, now let's find df dx, or basically prime. So we are going to differentiate first. Let's have a general way what you will have. So -3 over 2 times 3 over a, and x is going to be in the power -3 over 2 and -1, you'll get -5 over 2. And on top of that, you add 2a times 1 over 2, so we'll get simply a x to the power -1 over 2. All right, so we have negative powers, but that's okay. So f prime in general way, So f prime from x is going to be equal negative 9 over 2a x to the power negative 5 over 2, and we adding ax to the power negative 1 over 2. I'm not going to convert back into third form right now because here I need to plug f prime from 1. So we plug in x equals 1 right now, f from 1, and we know that the result is 2. So what we're going to do, we're going to plug x equals 1 everywhere, but we understand that it's simply sort of get rid of those x to the weird powers. And that means we'll get negative 9 over 2a plus a, and the result is going to be equal to 2. Okay, so what we're going to do right now, we're going to multiply everything by 2a. So before, we need to mention that a cannot be equal to 0. That's definitely because a is in denominator, and other values are eligible except for 0. So that's why we multiply both parts by 2a in order to get rid of the denominator, and we'll get the following. So 2a squared. I transfer 2 times 2a to the left side, we'll get negative 4a and minus 9. And what sort of equation we have? We have a quadratic equation. So right now we have purely quadratic equation in terms of a. Now solve for a. Okay, solve for a, and we're gonna use discriminant. So I just squeeze a little bit, so like this. Okay, and let's use quadratic formula using discriminant. So 4 plus minus square root of, so 4 squared is 16, and plus 4 times 9 and times 2, so it's going to be 8 times 9, 72, and over 2 times 2 is going to be 4. Okay, so make sure you remember how to work with quadratic function. If not, just go to reference for GCC how to use quadratic formula if you forget this. Okay, a from here will get 4 plus minus, and 16 plus 72 will give us 88, and square root of 88 we can simplify even more, 2 square root of 22 and over 4. Okay, on top of that, oh yeah, there is nothing to do with square root of 22, so that's why all a's that are eligible for us. So let's divide partially by 4, so we'll get 1 and plus minus square root of 22, square root of 22. Oh, okay, let's leave as it is. So square root of 22 and over 2. Okay, so that's the final solution. That's the final solution. Okay, I just put it in a rectangle. What's going on with that? Okay, yeah, finally I got it. All right, so that was sort of like basics and medium level question. So this is sort of medium level, and in the next video I'm going to consider that challenging problem. That's pretty challenging, sort of like PEP, I think P question. All right, so hope you like that, and don't forget to visit A-Level Zillion's classes and check out the videos dedicated to A-Level on my channel. See you next time.